We're going to look at a tool for organizing quantitative data so that we can properly display it. And this tool is called a frequency table. So if you have a wide range of quantitative data, how do you decide which points do you lump in together? So for example, you can see in this histogram of test grades, here I broke it down into groups of 10, of width 10 really. And so the bars represent the data points in each class. You can see I've got 3 kids that in this example that got somewhere from 49.5 to 59.5 on their tests. The height of the bar represents the number in each group. And the classes touch. They do not skip values because it's possible if I was doing, say, a straight fraction of correct that you could get a zero point 0.5 on a grade. And the interesting part is if you have a 49.5, it goes in this group. A 59.5 signals that you're going to the next group. So how do we build this histogram? First, you really should build a frequency table. And we're going to, here's some Snapchat data that I pulled from a class. And I said, what were your longest Snapchat streaks? Now, I have several zeros in there because there are a lot of kids who actually don't use Snapchat. But then I have a really high number of 730. So we went through and counted all this data and found out we had 33 points. So N is the frequency for the data, which is the total number of data points. Now to build our table, we're going to need 3 values. We're going to need the range, the number of groups, and the class width. And from that, we can figure out quite a bit. So step 1, we're going to determine the range, which is I need the maximum and minimum, which I'll subtract to get the range. The minimum on my data is 0, sorry, and the maximum is 730. When I subtract those two, I get a range of 730. Since my minimum is 0, I'm going to see some interesting stuff on my boundaries, but it won't be the end of the world. Now, how many groups do I want to have? Well, if you're going to have a histogram, having just 3 doesn't seem enough to see any shape. So you want at least 5 groups to determine a shape. And if you have a lot of points, you can actually have more. You can have up to the square root of n groups. So we have 33 data points. That's 5.7. So I guess we could use between 5 and 6 classes, but we'll just go ahead and stick with 5. Now, to determine the width of those bars, we need to determine the group width or the class width. And the way we do that is we take the whole range of data and divide it by how many groups we're going to have. So that's range divided by the number of classes. In our case, and then we're going to round up to the nearest integer, and I'll explain why. So if I take 730 and divide by 5, that's going to give me 146. I'm actually going to round it up to 147. The reason is in my first few groups, I'm going to stop right at 730. 730 is actually going to go into group 6. So you want to make sure that you round up so that when you put all those groups and bar widths, it covers your whole range. So it needs to be just a touch bigger. So now that we've got this basic information, we can start constructing our frequency table. And we start by focusing on what are called the class limits. The lower class limit is the lowest data point that can fit in a class. And for the first lower class, that's just going to be our minimum from our data. So in our case, that was 0. To get the other class limits, we're just going to keep adding the class widths. So to get the lower values here, I just keep adding the 147. So 0 plus 147 is 147. Add in another 147, 294, 441, and 588. Now this upper limit is basically almost the class width away. You actually had to take 1 away, so you stop 1 short. So an easier way to look at this is what's 1 short of 147? 146. 1 short of 294 is 293. 1 short of 441 is 440, and 1 short of 588 is 587. But you're probably going, wait a second, I don't know what the next one is here, so I don't know how to figure this out. Well, the other thing you could notice that these are actually 147 apart. So if I add 147 to 587, that's 734, which makes sense. Remember, we wanted our groups to be just big enough to include that 730. Now, I do want my bars to touch on a histogram. So if I stop at 146 and then have a little gap where that 146.4 or zero point 0.7 would be before the 147, they won't touch. So I'm going to kind of bring both bars in so they do touch. What that means is every bar is going to kind of go out by 0.5 on the lower classes. So I'm going to subtract 0.5 from the left side. And I'm going to add 0.5 to the right side. So negative 0.5 to 146.5. So, and that's halfway between 146 and 147, so that makes sense. And then halfway between 293 and 294 is 293.5. So now you can see all of my bars are touching. Finally, now we get to doing the tally. And these are simply the marks that represent the data points in between the boundaries, all right? Now, do remember, if a data point is exactly on a boundary, so if I have it 146.5, that's going to get rounded up to the next higher class. So 146.5 would not go in this row. It would go in the next one. So here are the tallies for our data sets, which we counted. And then the frequency is just the sum of all those tallies. So the total number of tallies here is 20. Then we have 9, 2, 1, and 1. Now, another thing that might come in handy are class midpoints. And that's just the point halfway between the class limits. So it's in the middle of the boundaries. You can basically average the lower and upper limits for each class, and that will give you the class midpoint. So 0 plus 146 divided by 2 is 73. I can do 147 plus 293 divided by 2, and it would also work with these class boundaries, by the way. And then I will get 220. The other thing you could notice is how far apart are these? Well, if I subtract these two, believe it or not, I'm going to get 147, which is my class width. So the other way, I could just add the class width to keep getting the next value. Now, this gives me a basic frequency table, but there's some other frequencies that we like to look at, like relative frequency and cumulative relative frequency. So cumulative frequency is the number of data points in that class and lower. So the first row is the same as the frequency. It's going to be 3, because anything 59.5 and lower, well, actually right before 59.5 and lower, there are 3 points there. If I say 69 and lower, well, that would be the 3 and the 5. So I'm going to basically add the regular frequency to the cumulative frequency, and I get 8. And I can just now say 8 plus 12 is 20. 20 plus 9 is 29. 29 plus 8 is 37. 37 plus 2 is 39. Okay, so relative frequency is just the actual frequency, this column, divided by the number of data points, and change that to a percentage usually. So for this case, it's 3 out of 39 is 7.7%. Then 5, I'm not using the cumulative, I'm just doing the relative, and that's 12.8. And I just go and divide these numbers by 39, and there you go. The total percentage, by the way, for this column should add up to 100%. And I can check that here when I do what's called the cumulative relative frequency, which is basically the total percentage of data points in that class and lower. Well, the first row is the same as the relative frequency. And to get subsequent rows, I'm just going to add like I did before for the other cumulative. So 7.7 plus 12.8 is 20.5. 20.5 plus 30.8 is 51.3. 51.3 plus 23.1 is 74.4. Now you probably said, wait a second, that's not what you have written here. Well, the other way I could have done it is just taken the cumulative frequency and divided by the total number of points, which is what I'm showing you here. And it gives me the same thing. And these will all add up to 100%. So once you set up this table, then you are well positioned to go ahead and make some histograms and what's called an ogive. And we will do that in our next